side that was going, what rule is this?
Was just going nuts because it was a rule that nobody had heard about. Or not that well used. But let's face it, you often, if you were to do a fair catch, you would be too far away from the opposite field goal to even think about putting one through the uprights. But then you think about it in the NFL, this rule did exist. What would stop that player from taking a free catch? Because think about how far those kickoff returns or those kickoffs go right now. NFL kickers could easily, as a kickoff, they're already putting them through the back of the end zone. That might be something for a team to look at. Okay, we're down by 2. Make sure you call a fair catch rather than the Hail Mary, where they're doing the laterals, which there's been like one time that it was amazing, and then after that it doesn't work. So maybe, I don't know. I have no idea. So, of course, I am an unbelievable coach from my own couch. Dude, they should have. You're right, dude. All right. Was there any questions on last night's homework? Number 11. Take a look at that. All right. So number 11, what's goofy about this is they want you to solve by factoring. So you could move this over by subtracting it, bringing it over. So then you get 25x squared minus 36y squared equals 0. So now this is the difference of 2 squares. So this is going to break up to be 5x plus 6y and 5x minus 6y. So how are you going to solve this? I guess you're trying to solve for x. I would get to about this point and call this good. But if you were to try and solve it, you could try, I guess, to do this. Yeah. It says solve by factoring. So the key word there is solve. That means it's equal to 0. It means you're trying to figure out what x is equal to. So this is kind of a goofy problem because if I were to solve this, I'd subtract 6y here, and then I would divide by 5. 6y divided by 5. And this one I would add 6y and then divide by 5. So this is what x is equal to, but it's also kind of goofy that you're solving and you have a variable that moved over there as well. So I don't know if you would actually see this one on a quiz. If it was on one, maybe I'd point it out and just tell you to factor it or whatever. 12 is going to be done very similar. Okay. I had gone over this type of problem in the factoring, and I think it might have been on homework. Okay, if I just have that, what I'm going to do is I'm going to ignore the y's for right now. I'm just going to ignore them. I'm going to keep in my mind that I'll use them in the end, but I'm going to say, okay, let's factor this. This right here factors to x minus 3, x minus 3. Okay, if I were to multiply that out, x times x is x squared. Minus 3x added together gives me minus 6x. Negative 3 times negative 3 is positive 9. Agreed? But what did we start to forget about? What was in the beginning that I'm forgetting about? The y. Okay, so the y here and here. So that means if I put the y there and if I put the y there, my answer is done. Now you're like, wait, that's not going to work. Well, x times x is x squared. X times negative 3y is negative 3xy. Negative 3y times x is negative 3xy. So negative 3xy, negative 3xi, added together is negative 6xy. And then negative 3y times negative 3y is positive 9y. Okay? And again, if we said to solve that, was that a solve? Yeah. So then again, it says to solve it. So that's it factored. So you have x minus 3y equals 0. So x is equal to add 3y to both sides. And then if you rewrote your other problem, and you have this as well, so it's the exact same answer. So I guess x is equal to 3y on this problem. Okay. What else would you like to see? 18. Okay, solve each polynomial factor completely. 13. 8x squared minus 18 equals 0. Okay, so I think I have a greatest common factor of 2, so I could divide everything by 2. And that's going to give me 4x squared minus 9 is equal to 0. Is that okay so far? And 4x squared minus 9 is what? It's the difference of two squares. So that's going to break down to 2x plus 3 and 2x minus 3. And then you'd set each of those equal to 0. So 2x plus 3 equals 0. Subtract 3. Divide by 2. And then 2x minus 3 is equal to 0. So I get this. It's positive 3x divided by 2. So there's my two answers. So negative 3 halves and positive 3 halves. What else would you like to see? 2, 2? Is that what you said? All right. 22. It's kind of a gotcha question. Good one to look at. Okay, quick question. Is x to the 4th a perfect square? What times what would give me x to the 4th? X squared times x squared, right? So then is y to the 4th a perfect square? What? Yeah, so this is the difference of two squares where you have these larger exponents. So this is going to break down to x squared plus y squared and x squared minus y squared. Okay, so let's take a look at this. If I want x squared times x squared, I get x to the 4th. Agree? Outside, x squared times minus y squared is going to be negative x squared y squared. Inside, if I multiplied positive that, I'm going to get positive x squared y squared. So I had a negative x squared y squared and a positive x squared y squared. They cancel out. And then y squared times negative y squared is negative y to the 4th. Now this is a cheap, dirty, rotten trick. Okay, so if you got this far on this problem, I'd make it worth 3 points. And I'm going to give you minus 1 at this point. Does anyone see why? Do what?
Can you unsquare?
Unsquare it where?
The x's and the y's.
What is this? What?
X minus.
It's the difference of two squares. So this will not factor any further. This stays as is. But this is the difference of two squares. So I get x plus y and x minus y. So you have a combination of difference of two squares in that problem. That's a dirty, rotten trick. Because you're so stoked that you recognize x to the 4th and y to the 4th are difference of two squares. But then once you factor it, you factors down into another. So does this make sense that this is not the difference of two squares? That's the sum of two squares, excuse me, with the hiccups. Where? Yeah. 15. All right. I think we need to multiply it out. So this here breaks down to x plus 2x plus 2. That would be multiplied together. This, I'll just distribute the negative 4 over both. And plus 4. Okay, so let's then multiply this out. So this, if I FOIL it out, it's going to be x squared plus 2x plus 2x plus 4 minus 4x minus 8 plus 4. Is that okay so far? So then let's clean this up a little bit. I have x squared by itself, so I have x squared here. I have 2x, 2x, minus 4x. They're gone, right? So that's gone, that's gone, that's gone. And then I have this, and this, and this. They're gone as well. So then I get this. Everything cancel out, right? So I get x squared equals 0. So what's x have to be equal to? 0. Done. Kind of a goofier one. Any other problems you'd like to take a look at? 17. 81y squared minus 36y plus 4. That's a great one to ask about. Okay, number 17. 81y squared minus 36y plus 4 equals 0. It doesn't appear to have a greatest common factor in there, does it? Nope. So if you tried factoring it our traditional way, you'd go 4 times 81, which is 324. Okay, let's do all the factors of 324. That would both be a negative. That would add up to 36. So that might be one way to do it. Or you could realize, oh, did I forget the x squared there? I'm sorry. All right. So y. Thank you. All right. So what you might realize is that a perfect square?
Yes.
Yeah. Is this a perfect square?
Yeah.
Okay. So this might work. We have to double check it. So 9y minus 2 and 9y minus 2. And I'm choosing it's negative and negative because that's a negative there. So let's see if this would work. If I were to multiply outside, I get 9y times negative 2 is negative 18. Negative 2 times 9y is negative 18. Negative 18y and negative 18y added together to give me this. So this one did work out. This is equal to 0, so you have 9y minus 2 equals 0. Add 2, divide by 9. And if I did the same thing here, this is the exact same thing, yes? So I get y is equal to 2 over 9 as well. Hey, what would happen if I had graphed this parabola? What would happen at that point? Yeah, it bounces off the y-axis. It's double root. It won't cross the y-axis twice. It just bounces. This would have to be where our vertex would be.
Will this one be sideways,
No. No. They're just using it as y equals, or y versus x. You can label your xy axis whatever you want. We always just stick with x and y as two numbered lines put together. But it could be anything you want. That's where science gets into it, saying, oh, this is going to be time and this is going to be temperature. And so, the same idea. Any others you'd like to see on that worksheet? Who, where? 24. Oh, okay. Find the area of the shaded region. Oh, that's kind of goofy. All right, so I have like a square, it looks like. Then I have this inside of it. And they want us to find the area of the shaded region. Okay. So let's see. This is S by 4S. So that's the little rectangle. And this is T and T by T. Okay. So how do I find the area of the big square? How do I find the area of a square? Yeah, it's going to be T times T, which is going to just give me an answer of T squared. Now I want to subtract that rectangle out. So if I wanted to find the area of the rectangle is base times height, right? Which is S times 4S. If I multiply that together, I get 4S squared. Okay? So T squared is the entire area. 4S squared is a little rectangle. So if I just subtract the two from each other, you get that. I guess you could recognize this as the difference of two squares, realizing it's T plus 2S and T minus 2S. That's basically how you do it. All right, if you would, pass forward your homework. If you're handed in any other assignments as well, that's fine too. Make sure your name is on anything you hand in, though, please. Oh. crazy rule about that? You gotta bring that up. Hey, Logan, we got this fair catch rule. Take everything as a fair catch and try a field goal as a kickoff return unit. It would make sense on a kickoff return because then you have your fast people in because theoretically the other team could receive it and run it back.
Is that your? I'm just gonna.
Unless it goes through the uprights, then they can't receive it because it went above them.
Sir, but put the homework on your desk.
Oh, you're awesome. Thank you. I like your Adidas shoes. Good kicks. All right, let's take a look at some notes for today. Everything going all right? We got, man, we are trucking along with this end of the school year.
We got like 3.
Yeah, it's quick.
Yeah, like 3 weeks after.
All right. Solving quadratics by using square roots. I could solve a quadratic equation using square roots, simplifying the radical. Okay, so this is another way that you can go in through and solve these problems. Okay, so we have something to pull out here. Oh, here's our perfect squares. Why is that one clear? All right, so perfect squares. Let's just put. Let's move that down here. Whoa! Oh boy! All right. So let's do this. Let's see. Can I break this up? So let's see. 5 times 25 is 125. That means 5 times 5. So if I went 5 times 5 times 5, I would get 125. Would you agree with that? And if I'm looking for a square root, how many of a kind am I looking for? 2 at a time. So if I take the square root of those two, what comes outside? 5, and then what's left inside? So square root of 125 will break down to 5 square root 5. Okay. So no matter what happens on number 2, whatever I pull outside needs to be multiplied by 2. Yeah, some of it's review, and then some of it we're just kind of going to start building. Okay, so whatever I take the square root of and it comes outside has to be multiplied times 2. So let's do this. I know that 2 times 36 is 72. Agreed? And 36 is 2 times 18. Do you all agree with that? And 18 is 2 times 9. Do you agree with that? And 3 times 3 is 9. Now, for those of you who didn't catch that, ready? Let's see if we can get this back to 72. 2 times 2 is 4. Times 2 is 8. Times 9. 8 times 9 is 72, right? So how many of a kind am I looking for right now? 2. So this comes outside, and 3. So the square root of that is what? 2. The square root of that is what? 3. I have this 2 already outside, so I have 2 times 2 times 3. What's still left inside? 2. What should I do to clean that up? Multiply. 2 times 2 times 3 is 12. So 12 square root 2 is the cleaned up version of 2 root 72. Okay, number 3, I'm multiplying radicals together. So remember, I can multiply outside and outside and inside and inside. Okay, so I'll multiply outside, outside. That just gives me 10. But I think a better way to look at this is, let's break 15 down. That's 3 times 5. Let's break 20 down. That's 2 times 10. 10 is 2 times 5. Okay, so I'm multiplying 15 and 20 together to give me 300. But then, so let's double check this. 15 times 20 is 300. So let's see if that can work. 5 times 2 is 10. 10 times another 10 is 100. 100 times 3 is 300. So do we have 300 underneath the radical? Yeah, but I want to start breaking this down. So I'm looking for pairs. So I don't have any 3s, but I have a 5 and a 5. So what comes outside? 5. That 10 is right there. Times another 5. Do I have another pair in there?
2.
Yeah, what's the square root of that? 2. So that 2 comes outside. What stays inside? 3. Let's clean this up. So 10 times 5 is 50, times 2 is 100. So 100 root 3. Okay? So 5 square root 15 times 2 square root 20 comes out to 100 square root 3. Can I move forward? Is that okay? Questions? All right. So we've seen that before. Okay, so we have solved linear equations. So this top one, you would add 6, divide by 2, and that's done. Okay? We just looked at that the other day, and we've taken a look at that a couple times. That was first semester stuff. Okay, absolute values. How many answers do absolute values have? Has 2. So remember with absolute value, you go 2x minus 5 equals 11, so you just drop them. And then you also do 2x minus 5 is equal to what? Negative 11. Because remember, absolute value is just a distance. And the distance is not a negative component, but you're talking about a distance away from the number. So this becomes 2 linear. So add 5, divide by 2. I get x equals 8. Yeah. Oh, you have a 600s?
Yeah.
Yeah, you could change it to a 5. I'm sorry. I didn't realize they had goofed that up. All right, so let's see. If I add that 5 over here, negative 6, and then x equals negative 3. Yeah, I guess on yours, they had changed that, so make sure you make a modification on yours. And then we get to the quadratics, which we've talked about. So I'll factor this quickly. This is going to be x minus 4 and x plus 1. It would factor the way you know how to factor it, but I'm just, for sake of time, making sure we can do it. So this gives me x equals 4 and x equals negative 1. Okay? So notice the absolute value, you have 2 answers, but you're solving the linear. But it's because it's a distance. Quadratic has 2 answers as well. So now, take a look at this. Most of you, what you would think to do is move the 18 over and see if you can factor it. Yes? But what if we were to do this? What if I were to add 6 to the other side? Would you agree with that so far? And then, what would undo a square root?
Square root.
Or a square root would. Now, the problem with a square root, can I go a positive times a positive and get a number? And a positive number? Can I go a negative times a negative and also get a number? That's positive, right. So if I had like negative 5 times negative 5, I get positive 25. If I go 5 times 5, I also get 25. So there's, being that you have 2 things, so if you take the square root of both sides, you have to have a positive and negative component to it. So I still have root 24. And now let's break down root 24. Now I understand you have a square root key on your calculator. You can go 24 and hit square root or square root 24, however your operating system works, and you're going to get 4 point whatever. I don't want 4 point whatever. I want an exact value. So let's break 24 down. So let's just break this down. 24 is 2 times 12. Agree? 12 is 2 times 6. 6 is 2 times 3. I'm looking for pairs. So what does root 24 break down to?
2 square root 6.
2 square root 6. Okay? So x is equal to plus or minus 2 square root 6. You need to have both components if you take the square root. Okay? All right? Cool. May I move off this screen? Cool. All right, so perfect square. So this is, look, it says get it equal to 0. And get x squared alone. Factor using difference of 2 squares. Pattern. Find the square root of both sides. Solve each factor. Remember there are 2 answers. Simplify answers. Remember there are 2 answers. So, did you guys have all of that written down? Cool. All right. So there might be some times where it might come out to the difference of 2 squares. Sometimes it might not. That top equation, if I went and said, well, let's subtract 5 from both sides, I'm going to get x squared minus 4. So this could have come out to x squared minus 4 equals 0, which breaks down to x plus 2, x minus 2, which breaks down to x equals 2 and x equals negative 2. Agreed? Or I could have went this way. I could have said, let's subtract 1, so I get x squared equals 4. Take the square root of both sides, so I get x is equal to, if I take the square root, I need to put what there? Positive, negative, and the square root of 4 is? So x equals the positive 2, x equals the negative 2. X equals positive 2, x equals negative 2. Because, well, that's the exact reason. If I solve this doing this by subtracting 5, I get 2 answers. One's the positive, one's the negative component. If I take the square root of both sides, I have to have the positive and negative because I need both answers.
Okay, so if we put the positive and negative for all sort of answers.
Well, if you take the square root of 2 sides, yes. Cool. All right, let me move on. So if you are putting the square root sign, remember there will be 2 answers. Oh, we hit it. We answered your question. Okay? So if you're putting the square root sign, you're going to have 2 answers. All right, so let's do this next one. Okay? First step, let's start getting x by itself. So if I add 32 to both sides, would that be okay? If I divide both sides by 2, I wind up with x squared is equal to 16. When I take the square root of each side, I get x is equal to?
Positive, negative.
Yep, don't forget the positive and negative. Positive and negative 4. There's my 2 answers. Yes, you could put x equals 4, x equals negative 4. Or you could put x equals plus or minus 4. Same exact thing. Can I go forward? Next problem. Let's think about this. What should I do? Doing it our new way. Add 12. Is that all right? So I get 3x squared is equal to 24. Divide each side by 3. X squared is equal to 8. I'm going to take the square root of both sides. If I took the square root, I need to make sure I put a plus or minus. X is equal to plus or minus square root 8. Let's break square root 8 down. That's the same thing as 2 times 4. 4 is the same thing as 2 times 2. Looking for pairs. So 2 square root 2 is the same thing as square root 8. So what should my answer be then? X equals what?
Positive,
Plus or minus 2 root 2. Done. Life good?
Yeah.
Woo! Example 4. Add 20, yes? So I get 2x squared equals 40. Divide each side by 2. X squared equals 20. Take the square root. Don't forget the plus minus. X equals plus or minus root 20. We have to remember root 20 will break down to 2 times 10. 10 breaks down to 2 times 5. So what does root 20 break down to? 2 root 5. Awesome. And there's the plus or minus. Do not forget the plus or minus. That's going to be a point. Problem number 5. Let's subtract 27. Is that okay? Let's divide by 3. X squared equals negative 9. If I take the square root of each side, don't forget the plus or minus, plus or minus square root negative 9, what would the square root of 9 be? 3. All right. Little hint, this is varsity math. Plus or minus is still there. If you have the square root under a radical sign, you're going to put the letter I. So plus or minus 3i. So if you have a square root and there's a negative underneath, now you're going to start bringing an I out. Okay? I stands for the imaginary number system, which is the largest of our number systems. Okay, the imaginary number system encompasses all the rational, irrational numbers, all of the real numbers, and then anything you have a square root underneath. How I works. just a quick, weird way when you deal with I. Imaginary numbers are this. They repeat every 4. This is that, this is that, this is that, this is 1, this is root, and it repeats. It repeats every 4. Okay? You don't necessarily have to have that down. Don't panic if you don't. Okay? So, your assignment will be page 145, 146. Page 145, 146 for Monday.
Yeah.
Sound good? Man, and happy Cinco de Mayo, everybody. Hope you have a great weekend. You have about 4 minutes left, so please don't line up by the door yet.